Imagine that you wake up early in the morning and go to the window. You're looking east, waiting for the sun to appear over the horizon. But it doesn't appear. You go out into the street and you see a bright sunny disk right above your head. Or perhaps the sun, for some reason, has appeared in the west, where it usually sets in the evening. At this moment, you understand with horror, all the planets have begun rotating in the opposite direction. What now awaits us and the other celestial bodies in this inverted solar system? Currently, 6 out of the 8 planets rotate around their axes in the same direction in which they move around the sun. Earth is one of them, but this is only for now. If you think that this will always be so, let's take a look at Venus. The planet is like Earth in mass and gravity. It's sometimes even called the sister of Earth, and at the same time, Venus seems to be turned upside down, rotating in the opposite direction of its movement around the sun. Billions of years ago, some unknown force turned its axis almost 180 degrees. How did it happen? According to one version of events, this happened because of its proximity to the sun. It seems to have pulled in a dense Venusian atmosphere. First, Venus' rotation stopped and then started again, but in the other direction. However, if we're talking about planets' axes of rotation, then there's an even more unusual example in the solar system, Uranus. Its axis is tilted almost 98 degrees, so this planet is now lying on its side. Now, let's imagine that something similar happened to Earth. If one morning you saw that the sun hadn't risen in the east, then something would be wrong with the Earth's axis. At the moment, its angle is 23.5 degrees. It's gradually changing, but within fairly narrow limits. According to one theory, this is due to the moon. Its gravity keeps our planet's axis from strong oscillations. The current angle of incline is just sufficient for the change of seasons to take place on Earth. Now, imagine that the moon ceased stabilizing our planet. As a result, fluctuations in the angle of the Earth's axis would become much more significant. They would be between 0 and 85 degrees. An angle of 0 degrees would lead to a complete absence of seasons on the planet. If the angle of Earth's axis approached 85 degrees, our planet would be in the same situation as Uranus is now. It would be a total apocalypse. For almost 6 months of the year, the sun would be at zenith above each of the poles. The heat would be so strong that all the polar ice would melt almost instantly. Well, on the other hand, the equator would receive less heat. Popular tropical resorts would suffer from cold and snowfall. Because of the melting ice, the level of the world ocean would rise and the water would flood many cities and even entire countries. It seems that this situation is quite out of control, so let's model a more imaginable change to the planet. Suppose that the Earth's axis didn't shift by just 85 degrees, but 180 degrees. Then it would just rotate in the opposite direction. The consequences wouldn't be so terrible, but still significant. As you know, the rotation of the Earth around its axis affects the movement of air masses. With a change in the axis of rotation, trade winds would begin to deviate in a western, not eastern direction. So, what would this lead to? Scientists at the Max Planck Institute for Meteorology have modeled the climate of an inverted Earth. The result is stunning. For example, the Sahara, the largest hot desert on Earth, would turn into a green savanna. Heavy rains would allow dense grasses and shrubs to grow there. At the same time, the southeast coast of the USA would become a real desert. The states of Florida and Georgia would no longer suffer from heavy rains, only from drought and dust storms. On an inverted Earth, residents of Western Europe and Central Europe would face another serious problem. Severe frosts and frequent snowfalls would thoroughly ruin their lives, and Great Britain could turn into a harsh, icy land. It would be as cold there as it is now in Alaska or northern Canada and Russia. it seems it might be better to escape from such an inverted planet. But to where? We could try the moon, but
Houston, we have a problem.
the moon wouldn't be in the same place it was before. The fact is that in the usual solar system, lunar gravity slightly changes the shape of the Earth, creating a slight bulge on it. This bulge shifts as our planet rotates. Currently, the speed of Earth's rotation around its axis is faster than the rotation of the moon. Therefore, as it rotates, the Earth transfers part of its energy to the moon, as if it's pushing it into a higher orbit. This phenomenon is called tidal acceleration. Due to this, the moon moves away from our planet at a speed of about 3.8 centimeters, or 1.5 inches per year. So, if the Earth began rotating in the opposite direction, tidal forces would then slow down the moon. In other words, if we turn the axis of our planet 180 degrees, the moon would begin approaching the Earth's surface. As a result, in a few billion years, gravity would bring it too close to the Earth. At some point, tidal forces would simply tear it into thousands of fragments. Instead of our usual moon, we would probably have a small but charming planetary ring, something like Saturn has now. What's more is that tidal forces act not only within the Earth-Moon system, but the satellites of other planets are also subject to tidal deceleration. Because of this phenomenon, a terrible moonfall would begin in the solar system. Many planets' satellites could perish. For example, Phobos, one of the two satellites of Mars, it previously rotated around Mars faster than the planet itself rotated around its own axis. Tidal forces slowed Phobos down and it began dropping. A 180 degrees rotation of Mars' axis would accelerate this process and boom, another moon would disappear. Something similar could affect other cosmic bodies. For example, two of the moons of Jupiter, Metis and Adrastea, or immediately to all 11 of Saturn's moons. Each one would collapse in the same way. However, a change in Neptune's axis of rotation could, on the contrary, save its largest satellite, Triton, from certain death. It's already spinning in the opposite direction of Neptune, and right now, Triton, under the influence of tidal forces, is steadily approaching its planet. Someday, it will be too close to Neptune. But if the planet changed its direction of rotation, tidal forces would begin accelerating Triton and push it into a higher orbit. Neptune's largest satellite would be saved. At least one piece of good news for today. But where could people escape to if all of a sudden the whole solar system began spinning in the opposite direction? Here's an idea. Let's go back to Mars. Despite the fact that a 180-degree shift of its axis would provoke Phobos to fall towards it, there's another option for the way things could unfold. As you know, scientists have long been trying to find extraterrestrial life on Mars. So far, their attempts have been unsuccessful. One possible reason is its weak magnetic field. This protects the ozone layer, which is necessary for life and helps preserve water in the atmosphere. Due to its weak magnetic field, the solar wind picks up Mars' hydrogen molecules and carries them away into space. Scientists believe that for this reason, Mars has become deserted and lifeless. But if Mars began rotating in the opposite direction, its conditions could become closer to those on our beloved Earth. This would be aided by a phenomenon known as axial precession. To understand it, imagine that the direction of a planet's axis is gradually changing. Now, put a coin on its edge and spin it. At some point, it will begin deviating from side to side. The same thing happens slowly with the axis of the Earth and other planets. There's evidence that this contributes to the emergence of a magnetic field. If you flip Mars' axis 180 degrees, it would also slowly deviate, but in the opposite direction. Who knows? Maybe after something like this, Mars could develop a powerful and stable magnetosphere. A stronger magnetic field would help maintain a denser atmosphere over time. So, if the planet suddenly began rotating in the opposite direction, now you know where to move to. Don't forget to like this video and share it with your friends. Perhaps they also really need to know what to do in case of such unforeseen circumstances. And click on the bell to not miss new videos that are waiting for you and your friends ahead. Until next time.